Hi YouTube, continuing question 6, further Pure 1, 2008, sigma notation, part A, partial fractions, method of differences in B, and between 30 and 21 in C. So for the partial fractions in A, considering A over R plus 1 plus B over R plus 3, multiplying both sides by the lowest common denominator gives this identity, and then substituting r equals minus 3 and minus 1, we can write down the form required. So for part B, the method of differences, using the partial fractions from A for the expression and applying to 5 terms and subtracting gives a half plus a third minus 1 over n plus 2 minus 1 over n plus 3. And simplifying this expression simplifies to the proof required. So between 30 and 21 for C, using the proof from B for the expression, and considering 30/21 will be 30 minus 20, substituting n equals 30 and n equals 20 into the proof from B gives the exact value and the approximation. So the partial fractions, the proof required, and the exact value. Question 7, calculus substitution. To show the substitution transforms 1 to 2 in A, and then by solving equation 2 to find a general solution of 1 in B, and a particular solution of 1 in C. So differentiating the substitution implicitly gives an expression for dy dx, and substituting this in equation 1 simplifies to the proof required, equation 2. So for a general solution of 2, we see it separable. So separating and integrating both sides gives a general solution. And then considering the form required, simplifying further and using the laws of logs, where a equals e to the power 4c, and then considering that v is y over x and substituting for v, simplifying further gives an expression for y squared, and the form required, y equals the root of this expression. So for a particular solution of 1, given y equals 3 at x equals 1, substituting these values in the expression for y squared gives a as 19, then we can write down the particular solution. Final question in this paper, question 8. Polar coordinates. To show that the point P has polar coordinates 2 pi over 3, and to find the exact area of the shaded region in B. So to show that P has these coordinates in A, considering P is an extreme point, then dx d theta will be 0, where the x coordinate is r cos theta. So substituting the polar equation and differentiating, setting to 0. From observation we see that cos theta will be a half, So theta will be pi over 3. So for polar coordinates r theta, when theta equals pi over 3, r will be 2. So giving the proof. So for the exact area, considering the line theta equals pi over 2 and at p theta equals pi over 3, considering the triangle OPN, then the area from observation, the area will be given by the standard integral for the area for polar coordinates plus the area of the triangle between pi over 3 and pi over 2, where r is the polar equation given and where theta is pi over 3 for the triangle. So evaluating for the triangle where theta equals pi over 3, the triangle evaluates to root 3 over 2, and considering r squared for the area, using the identity for cos squared theta and adjusting the integral and simplifying to here, and then applying integration. Simplifying gives the exact area as 2 pi minus 16 plus 15 root 3 over 2. So the integral for the area required, and then integrating and adding the area of the triangle, exact value required. Thank you for watching. I'll start further pure 2 in the next video.